Hello students, I welcome you once again to our SHS 3 Core Mathematics program brought to you by the Center for National Distance Learning and Open Schooling. My name is Ben. We are going to continue with our discussion on the topic mensuration. In our previous lesson, we discussed volume of a sphere. Today we shall look at another aspect of a sphere, which is distances of arcs of spheres. By the end of this lesson, you will be able to 1. Draw a sphere and indicate 2 points on the same latitude or on the same longitude. 2. You will be able to calculate a distance along a given latitude, which is a small circle. 3. You will be able to calculate distance along a given longitude, which is a great circle. The Earth rotates about its axis and it is considered as a sphere. The vertical axis is a line of symmetry which passes through the North Pole and the South Pole of the Earth. There are imaginary lines on the Earth's surface called lines of latitude and longitude. These lines are used to locate the position of any point on the Earth's surface. Lines of longitude or meridians are imaginary great circles on the surface of the Earth, which passes through the North and the South poles at right angles to the equator. All the points on the same meridian have the same longitude. Longitudes are measured in degrees, east or west of the polar axis. All lines of longitude, that is the meridian, are great circles. This is because they divide the Earth into 2 equal halves. The equator, which is latitude 0 degree, is also a great circle because the equator also divides the Earth into 2 equal parts. The lines of longitude are drawn from north to south, and the lines of latitude are drawn from east to west. The radius of the Earth varies between 6,357 kilometers and 6,378 kilometers. But usually, the radius is given as 6,400 kilometers for easy calculations. That's an approximated value. The arc P prime is known as a longitude. The arc AC is referred to as a latitude. The spherical distance between the 2 points P and Q on a sphere is the distance of the shortest path along the surface of the Earth, as shown in the diagram. Let's look at calculations involving distances on a great circle. From the figure, the distance PQ is an arc. But from our previous lessons, we learned that the length of an arc is obtained by using the formula S equals theta divided by 360 multiplied by 2 pi r. In the same way, the formula can be used to calculate the distance between the points P and Q on the surface of the Earth. From the diagram, you can see that P and Q is on the circumference of the circle. Therefore, the distance between P and Q is an arc. So PQ is equal to theta divided by 360 multiplied by 2 pi r, where r is the radius of the great circle and theta is the angle subtended by arc PQ at the center of the earth. Let's look at a very simple example. Find the shortest distance between the 2 points A, which is on latitude 25 degrees south and longitude 30 degrees east, and the point B, which is on latitude 35 degrees north and on longitude 30 degrees east, along the line of longitude. We take our radius to be 6,400 kilometers. Now the solution. The first step is to try and draw the graph to illustrate the 2 points. The two towns have a common longitude, and this means that the distance is on the longitude. Again, the 2 points have different directions. That is, one is on 25 degrees south and the other 35 degrees north. Therefore, we shall add the angles to get the latitudes between them. That is, the angle between the two towns will be equal to 25 plus 35. Therefore, our theta is 60 degrees. So the length or the distance between the two towns AB is equal to theta divided by 360 multiplied by 2 pi r. Here our r, which is on a great circle, is 6,400 kilometers. So we do our substitutions, and we have AB equals 60 divided by 360 multiplied by 2 multiplied by 3.142 multiplied by 6,400. If you use our calculator, then we are going to get 6,702.9333. If you approximate to the nearest whole number, then the distance between A and B is 6,703 kilometers. That was very easy. You just have to identify the appropriate formula, which is the length of an arc. Then you do the appropriate substitutions. Let's take another question. Find the distance between P and Q if their positions on the surface of the earth are latitude 48 degrees south and longitude 41 degrees east, and latitude 60 degrees north and longitude 41 degrees east, respectively.
Action.
Take the circumference of the earth to be 40,000 kilometers. Let's look at the solution. You first try to illustrate the 2 points on the diagram. The two latitudes are 60 degrees north and 48 degrees south. They are on opposite sides of the equator. So to obtain the angle between them, we add the two values. Therefore, our theta is equal to 60 plus 48, and that gives us 108 degrees. We have been given the circumference of the earth to be 40,000, and we know the circumference of a circle is 2 pi r. Therefore, 2 pi r is equal to 40,000 kilometers. Now we are calculating the length of the arc PQ, which is the distance between the two. And that formula is theta divided by 360 multiplied by 2 pi r. If you do the appropriate substitution, then we have PQ to be equal to 108 divided by 360 multiplied by 40,000. If you use our calculators, then we have 12,000 kilometers. So we conclude that the shortest distance along the line of longitude between P and Q is 12,000 kilometers. That was very, very easy. Let's look at another example. Find the shortest distance between the 2 points X, which is on latitude 0 degrees and longitude 20 degrees west, and Y, which is on latitude 0 degrees and longitude 10 degrees east. 1. Along the line of latitude. 2. Through the earth. Now we take R to be 6,400 kilometers. The solution. You first draw your diagram and locate the points. Now the 2 points X and Y have a common latitude, which is 0 degrees, and that's the equator. Therefore, the distance between them is on that circle, which is a great circle. Again, the points are on the opposite sides of the pole. That is, one is on the west and one is on the east. So to find the angle between them, we add the two angles. So in this case, our theta will be equal to 20 plus 10, and that is 30 degrees. The distance along the line of latitude is equal to xy equals theta divided by 360 multiplied by 2 pi r. If you do our substitutions, then we have xy equals 30 divided by 360 multiplied by 2 multiplied by 3.142 multiplied by 6,400. If you use our calculators, they are going to get 3,351.467, and that is approximately 3,351 kilometers. Therefore, the distance along the line of latitude is 3,351 kilometers. Let's look at the second part of the question. We are to find the distance through the earth, and this distance is referred to as the chord between X and Y. It is very important to note that we have two types of shortest distances, and these are: 1. Shortest distance along the lines of latitude or longitude, and we have just the shortest distance. Action. The shortest distance through the earth refers to the chord XY. Now from the diagram, you can see that the chord XY is equal to 2 multiplied by ZY. Again, from the diagram, you observe that OZY is a right-angled triangle. Therefore, we can use trigonometry in calculating any side of the triangle. From the triangle, we can observe that sine 15 degrees is equal to ZY divided by R. That's if we apply our trigonometric ratios. This will simplify to ZY equals R multiplied by sine 15 degrees. But we know that the chord xy is twice zy. Therefore, the chord xy is equal to 2 times r times sine 15 degrees. We know the value of r, which is 6,400. And our sine 15 from the calculator will give us 0.2588. So we do the necessary substitutions, and we have 2 multiplied by 6,400 multiplied by 0.2588. When we use our calculator, we are going to have 3,312.64. To the nearest kilometer, we have 3,313 kilometers. That was very, very easy. This is a very simple work that you need to practice so that you can become perfect. In this lesson, we have learned that 1. Using the formula, we can calculate the distance along a given latitude and a longitude. 2. The lines of longitude are drawn from the north to the south, and the lines of latitudes are drawn from the east to the west. We have also learned that lines of longitudes are imaginary great circles on the surface of the earth, and these lines passes through the north and south poles at right angles to the equator. Also, we have learned that all lines of longitude, that's the meridian, are great circles because they divide the earth into 2 equal halves. The equator, which is latitude 0 degree, is also a great circle. That's good. Well. This brings us to the end of our discussions on distances of arcs of spheres 1 under Mensuration II. In our next lesson, we shall look at the second and concluding parts of distances of arcs of spheres. I hope you have learned a lot, and you will keep practicing a lot more questions on all that we have been discussing on this program. Join us again for the next lesson. Till then, bye-bye.